So in this video, we are looking at problem solving with related rates. Now in example one that we did, you were given an equation that related two variables together and were asked to find the rate of change of y when x equals 1 given that dx dt equals 2. So it was easy because it was already set up for you. You just differentiate both sides implicitly and then plug in those values. Now in the next example here, we're going to actually have to create a mathematical model from a verbal description. So what does that mean? Word problem, right? All right. A pebble is dropped into a calm pond, causing ripples in the form of concentric circles. So circles, right? The radius of the outer ripple, this outer ripple, is increasing at a constant rate of 1 foot per second. So when the radius is 4 feet, at what rate is the total area, A, of the disturbed water changing? So we're talking about as R changes, notice that the area changes. So do we have a relationship between area and radius? Sure, we know that the area of a circle is just pi r squared. So we can actually differentiate this, right? dA dt equals pi is a constant. Don't differentiate with respect to t because it's a constant. So we're going to say 2 pi r and then dr dt. Now we're given that the radius is increasing at a constant rate, 1 foot per second. That means dr dt equals 1 foot per second. So we want to know when the radius is 4 feet, how is A changing? So changing means rate, right? The rate of change. We're looking for dA dt. When dr dt equals 1 and r equals 4. 2 pi times 4 times 1 equals 8 pi square feet per second, because we're talking about an area, right? Because that's 1 foot per second. This is 2 pi, that's 4 feet, right? So we got feet per second, we get feet squared per second. Now, that's the answer. Here are your guidelines for solving related rate problems. First, identify all the given quantities and the quantities that you need to figure out what are, and then make a sketch and label all of the quantities. Now, you want to write an equation involving the variables whose rate of changes either are given or need to be determined. So we're talking about looking for formulas for area, looking for formulas for volume, looking for Pythagorean theorem, right? If you've got a triangle that's changing, things like that. Then you want to use the chain rule, implicit differentiate both sides with respect to time. It's always important that we do that. And then last after completing step 3, we're going to substitute any of the information that we were given to solve for whatever the required rate of change was. So if you have any questions about solving these kind of problems, we've got a couple of these in the homework. So if you've got any questions on those, make sure you bring them to class or shoot me a reminder.